Here is a problem that requires us to use the distance formula. And so when we read through this, we see that he paddled downstream for 2 hours, and then he returned back to his starting point, and it took him 4 hours to get back. We found the total distance is equal to 16 miles. So we know that his trip downstream and then his trip back up, both of them are going to be the exact same distance. And so if we have a total of 16 miles, then we know that he traveled 8 miles downstream and then 8 miles back. So if we start filling in the distance formula, we know that distance is equal to rate times time. And so the distance downstream is going to be 8, and so is the trip back up. We need to fill in a rate and a time so that we can have two different equations and solve for them. But let's think about our two variables. So we know if he was paddling that he was using some of his energy, and so we'll let x represent the speed at which he paddled. And then we'll let y represent the current speed. So that when we get our final answer, we'll have how fast he was paddling, how much he was contributing to his total distance covered in a certain amount of time, and then how much the current either helped or hurt him. So remember, when you're dealing with distance problems in these chapters, most of the time they're talking about traveling with the current or with the jet stream if we're doing a flying problem. And then when you're flying against it, it's going to hurt you. So if we think about the rate here, his speed of travel helped, and so did the current speed because he was going downstream. And so he paddled, and then the current helped push him along as well. And he did this for 2 hours because it says it took him 2 hours to get to his initial turnaround point. And then on the way back, we know that it took him 4 hours. And when we think about traveling back upstream, yes, he was paddling, but the current was hurting how quickly he could move along. And so we have our two equations. We should distribute our time through onto both variables in both of these. We have 2 times our x plus y is equal to 8. And then we have 4 times x minus y is equal to 8. And we would distribute here and here. So we end up with 2x plus 2y is equal to 8. And 4x minus 4y is equal to 8. We can solve pretty easily for x in this first one, and so we will change our color, and we'll solve for this one now. So we've got 2x plus 2y is equal to 8, and we will subtract our 2y from both sides. We get 2x is equal to 8 minus 2y. Divide through by 2, everything. And we get that x is equal to 4 minus y. Now we can plug this in for x in our second equation. So we will rewrite it and say 4 times 4 minus y, and we make sure we use those parentheses, minus 4y is equal to 8. We'll distribute through, so we end up with 16 minus 4y. Minus 4y is equal to 8. We're going to subtract 16 from both sides. And then we get negative 8y is equal to negative 8. And then we can see that y is equal to 1. And notice that the question only asked for the current speed, but we'll go ahead and solve for the speed at which he was paddling as well. So we find that y is 1 mile per hour. It's fine. And then we want to find his speed at which he was paddling. And so we need to plug back into one of our original equations, either this one or this one. We'll go with this one up here, and we'll say 2 times x plus 2 times 1 mile per hour that the current was pushing him along or holding him back is equal to 8. We will subtract our 2 from both sides. We end up with 2x is equal to 6. And we get that he was paddling at 3 miles per hour. Here is a mixture problem. So we will set up our little beakers and fill in what we know. And we have information about percentages, and we have information about gallons. So on the top, we'll fill in gallons. On the bottom, we will fill in our percentages. So we know that we have a 30% solution of fertilizer, and we're going to mix it with a 60% solution to obtain 150 gallons of 50% solution. And we want to know how many of the 30% and how many of the 60%. So we've got our total over here, and it is equal to 150 gallons of 50%. And we are going to mix together some amount of 30% and some amount of 60% to obtain this final solution of 150 gallons of 50% fertilizer solution. Since we don't know how many gallons of the first one, we'll call it X. And since we don't know how many gallons of the second one, we'll call it Y. If we want to write our first equation, it's going to be an amount or a quantity. And so we're thinking about just how many gallons we have. Well, we don't know how many from the first one. We don't know how many from the second one, but we know that their total is 150 gallons. Then we want to write a worth type of equation. And on this one, we are going to include the percentages, and we always change our percentages to decimals. So we have 0.3 for my first one times however many gallons plus 60% or 0.6 times however many gallons of fertilizer for the second one. And then we will obtain a 50% solution of 150 gallons. We can go ahead and solve for one of our variables from the first problem up here and substitute into the other one. So we've got this yields X is equal to 150 minus Y. So we'll plug into our second equation here with that X statement. And so we'll have 0.3 times the 150 minus Y plus 0.6 times Y will give us 0.5 times 150. And we'll continue solving. When we distribute our 0.3 onto both parts, we get 45 minus 0.3y plus 0.6y is equal to 75. And then we can go ahead and subtract 45 from both sides. Get 30 is equal to, and then we'll go ahead and combine our like terms. So we have 0.3y. We'll divide through by 0.3 and divide through by 0.3. And we get y is equal to 100. So that says of the 60% fertilizer, we are going to need 100 gallons of it, and that leaves us 50 gallons left over to go from the 30% solution. It's always a good idea to check, and so we'll do that. If we have 50 gallons of the 30% and we add to it 100 gallons of the 60%, does that yield 150 gallons of 50% solution? When you check over here, you should get 75, and this side also equals 75. So good job.